that I have to end the class just for 1 hour today because I have to go to Taichung. Now I'm in Hsinchu, National Tsinghua University. So so I have to travel later. So I can only take 1 hour class with you. So tomorrow we'll still have we're gonna to have a class also. So then I will hopefully maybe I will just extend the class more time tomorrow. Okay. So can we start the class now? Are you girls and boys? Are you ready? Right. Okay. I'm gonna to share the check. Okay. Okay, now I need to do some adjustment because before that we have online class. Okay. So we stop here. 2 weeks ago, not last week. We don't have class last week. So we learn about the composites in general. Still, we are in the general topic. We are not yet arrive to the specific topic. Okay, so this is we also discuss, right, the alignment of the fibers, and that's divided into 2 long fibers, short fiber, and if this is a short fiber, we can arrange randomly. And some of the kids ask me how to do it, right? Well, in the industry, to them it is pretty easy. Example, they have very good manufacturing tools to produce it. It is not like Unimap. We don't have anything, right? So then you can't imagine perhaps, but anyway, when you work in the industries, then you may able to experience it. So we learn the theories, no? Okay. So aside from the fibers, now we can add into the different kind of matrices. We also can add like different fillers, like with a different structure. Example, a particle here, okay, flake, lamina, and those that we cannot identify, we do not know how to actually name them. So lamina, you know it very well. Flake is like a 2-dimensional material. Then particle is 3-dimensional. Then okay, so these are the example of the composites with different type of fillers, or in the way that we can say it is a reinforcement, right? So we learn what is the meaning of reinforcement. Kan? So we also learn the definition of reinforcement, and we learn the definition of filler. So I hope that next time when somebody asks you, when you go for job interview, you don't make yourself confused. Okay. Right. So I need some expression from you. If let's say I ask question, please respond. No, I just don't want to speak to myself. Okay, can I get some response first? Like maybe you put oh, thank you, Jaime, and then who else? I only see one. I think we'll have more. Okay, good. Right. So now, for first type is the fiber composite, which is we are going to learn in the following topics. We only focus on learning the fiber reinforced composite because this is the most the traditional and the first generation of the composite material, I can say. So composite material born is starting with this fiber composite. Okay. Okay, so here they have like reinforcement. This is 1 dimension, give maximum strength in a 1 direction. This one is short fiber, we know. This is chop strength, we say, like we have the mat, something like this, like the fiber arranged. So this one will even give higher strength to the composite, regardless of the position of the force being applied to them. And also the last one is randomly. We call it isotropic. Iso meaning that same, right? Same. So this type of randomly arranged fiber in the matrix. No? I don't want to say polymer yet, but in the matrix. So it can be polymer matrix, it can be ceramic, it can be metal matrix. So they will have a same strength regardless of how we apply the force to them. So you may ask, how about this, right? So this is somehow if we put the force in this direction, then it would be different from you push the force in this and this direction. No? So here, this is more even, provided, I always say, provided the manufacturing method is appropriate, right? The manufacturing parameters are appropriate. The amount of the fiber used is in its optimum. So then we only can say everything is good, but nothing is so perfect in this world. But anyway, the imperfection also brings something interesting. I just learned from some of the talks that I listened a few days ago. We are having a workshop right now, but I can't join the talk right now because I have to be with you. This is my job to be with you. Okay. The second type is the particle composite. No, so it is like a particle form. I think it is kind of very difficult to define. But usually we are looking for the particles material, the material in the particles form. It has even sizes. If possible, we would like to have, they have even sizes, they have an even structure. So meaning that if let's say it's a round shape, usually round shape or tetragonal or cubic or hexagonal, okay, these are all the particles structure. And if let's say we can have the material have the same structure, either it is round in shape, it is hexagonal, or it is cubic, then we know it is easy for us to make a design, to make composite. But there are a lot of cases is, a lot of cases are, it is not the case. The particles may come into a different forms, especially those from the natural resources, that because we cannot control, right? It is come from nature, whatever it give to us, then we just use it. But so those synthetic, then we can do something, we can make them into a same size, we can make them into a same structure, we can even use like synthesis method, use chemical synthesis method, because in our lab, we usually use synthesis method to produce nanoparticles. So we're able to control, use the parameters. We want it to be round, it can be round. We want it to be square, it can be square. So, but come from nature is quite difficult. So I would say, if you want to have homogeneous properties of the composite, then it would be ideal you choose the right, you choose the particle with most of them are even in size, no, and same structure. Then it will be easy for you to control the properties of the material. Okay, so there are a lot and plenties of different type of particles available in the world, and it can be in synthetic, it can become in natural. Okay, so the first one, this is the cement. So it's kind of an oxide material, the aluminum oxide, zinc oxide. There are different type of oxide. Okay, it always used as reinforcement or filler for the composite. Then have also the combination of the metal plastic particle composite. As we know, metal is conductive, right? We want to make, and is high resistance to temperature, but of course it's not oxide. This is much better. This is like, okay, high resistance, but metal will give ductility. Sometimes depends on the type of metal and its morphology, its structure and size. Okay, then the third is metal in metal, meaning that you have metal as matrix, then metal as filler or reinforcement. This can be done. It just depends on how we treat them. So the definition, sometimes we will say, right, metal plus metal is what? Two types of metal. If we have two types of metal together, in general, what is the material called? Yes, very good. So then, but somehow, in this case, it is not alloy. It is treated like composite. So we have to, that's why if we understand the definition, we understand the definition of alloy, we understand the definition of composite. So we are kind of very confident, say, okay, this combination is composite, this combination is alloy. So this is for the hardening effect. Anyway, sometimes people will say some of the metal, it is quite soft, and they add some other type of, actually is at the oxide, add carbon material or oxide material to harden the metal. So we call hardening the metal. It actually creates something like imperfection to the metal. If unfortunately you don't learn the general subject called Introduction to Material Science and Engineering, actually all the students, regardless of any specialization under the engineering program, they have to study this subject. But UniMaps, I don't know why the structure will be a little bit different from the rest of the world. So, but you should actually, in your first year, you should learn this subject, Introduction to Materials and to Material Science and Engineering. Then it mentioned about this, hardening effect on the metal and blah, 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 blah. Okay. But you only you only learn a little bit during the Introduction to Polymer. Right? So C is the flake. Flake somehow it's like a two-dimensional, but it is a thicker. It is thicker. You also maybe get confused. Two-dimensional like the film, like the very flexible film. You're gonna to make. I think a lot of you in the FIP project, you're gonna to learn about the making the film, right? So that is quite flexible. That is also two-dimensional material. But this one, flex, is also two-dimensional material. But the thickness is higher than the film. So usually it is not that flexible. So compared to the film type of the material, although they are in the same dimensional structure. Okay. Then where the flake can be aluminium flake, it can be mica, it can be glass. So we can make the glass into a different type of structure. We can make it into particle. We can make it into glass fiber, right? Into a fiber type. We can make the glass into flake as well. So you see, only one type of material we can make it. We can make them into a different size, structure, shapes. So it is quite interesting. That's why a lot. I just recently have a discussion with friends, and then they are very envy to us. We say the material researchers, the material scientists, always have fantastic idea, play around the materials, and then so they can just change a little bit, maybe the structure of the material, the size, then they can change the overall property of the products, or even in the research output. So that's why they say we able to come out with so many ideas, we able to come out with so many publications, or just play around these little things, and it make the overall result change dramatically. Okay. Then this one is flag. Okay, what are the benefits? What are the good properties of having this filler or reinforcement in the flag in flag structure? Okay, higher strength, blah blah blah. Okay, so it also depends on the material itself. Not all type of flags is like this. No, this is just general. It's general. It depends on the source. Maybe it is aluminium flag, right? Or maybe it's oxide flag. Then it's very huge. It's a huge difference among them. Okay, lamina, you know about lamina, right? So this layer 1 and then layer 2, layer 3, So basically, lamina composite consists of at least 3 layers. Okay, and you will learn this from Dr. Aslin at the second part of her class. So you will have 3 layers. Basically, you have 3 layers, but that 3 layers, we call it sandwich, right? You eat the sandwich. So it also considered in this one type of the lamina composite. So the basic one is a sandwich structure. You have the core, the face, and in the middle, I can't remember. In the middle actually is the core. Okay, so middle is core, and then the face and the bottom. Okay, so that is the simplest lamina structure of the composite. So stick 1 layer, 2 layer, 3 layers. Of course, it can be more layers, but we have to know that why we arrange the lamina composite in such a way. So there are something theory behind, there are some calculations behind. It can be very difficult to learn. As I know, it can be very difficult to learn, but I think Dr. Asling will show you the simplified version, how to calculate the strength if the lamina composites arrangement differently, something like that. Okay, so speedboats holes are among the very many products of this kind. So actually, not only the speedboat holes example, the lamina structure in our daily life, I can say I have a friend. He actually is like an elder senior. He's in the age of about, I think now he's in the age of about 70s already. So he sell, but now he sell his factory. I guess he's having we call it a luxury pension. Okay, previously he opened polymer manufacturing plant. Okay, so he actually produced packaging material, food packaging material, and to package the bread. You know, bread like gardenia. Like usually we buy gardenia, right? Gardenia, and what else? The brand can one of you name some more aside from gardenia that we buy from the grocery shop? Anyone can give an idea? Beside gardenia, we have another brand. If you are shy to talk, you can type. I would like to. Okay, Massimo, yes, true. Okay, thank you very much. So if I speak too fast, thank you. So if I speak too fast, I can't remember like 2 weeks ago, there's one boy come to me and he said that, Dr. Ong, can you please teach in Bahasa or mixed language? Actually, I myself don't really like to speak mixed language in my conversation, the reason I can tell you now, the reason is I would like my students to practice the right language. If you speak English, you speak English all the time. So if you speak Mandarin, Chinese, you speak Chinese, Mandarin all the time. You speak Malay, you just speak Malay all the time. This is a good practice that to enhance your language capability. So in Malaysia, we have this type of, I don't say it is a bad culture or not a good culture, but this is a unique culture that we like to speak multiple languages in our daily conversation. So if this become a habit, then it actually will, to me, I find out that in my own opinion, not just my own opinion. So I find out that the language ability of that kind of person would be lower. Yeah, so they can't really write very well. They can't really speak very well because they usually go and rojak. then the grammar wrong. And there's a lot of wrong things happen in the language, but so when you go out to work, you have to write report. Right? So your boss will say, your report has so many grammatical mistakes. I heard a lot from my friends before they share with me. So my intention is to let you all and myself, okay, together we improve certain language. So try to, like, when you have your own conversation with your friend, you cakaplah bahasa betul-betul. Janganlah campur ini, campur itu. That is my intention. Yeah. So bahasa, okay, cakap semua bahasa boleh, tak apa. If Mandarin, like Chinese, sometimes I speak Mandarin, you heard. So okay, then we speak Mandarin, and I try to don't mix other English word inside our conversation, unless we are talking about science, because it is quite difficult when you talk about science and we translate those we learn from English to Bahasa or to other languages, right? Okay, so if I'm too fast, please stop me, or please say, Dr. Ong, can you explain this? I am not very sure, I'm not very clear about, then can you explain it in Bahasa? You are always welcome. Okay, you are always welcome to ask this type of request, and I'm happy to speak Bahasa, no problem. But in the whole, if you don't stop me, I will keep talking in English instead. Okay, I can't remember who is the boy already. Maybe he's not in the class today. Okay, how come it's all the girls thumbs up? How about the boys? Okay, hi. Okay, so then the lamella, okay, just now I mentioned the simplest lamella structure is the sandwich. It consists of core, face, and base, no? Right. I will just move it. This one, it seems like very easy for you to understand. This is because lamella structure, lamella composite, there's a lot to learn. There are a lot things to learn under this lamella composite. But what you are going to learn is the simplified version, not difficult at all. But to design lamella composite, it is not as simple as what we imagine. Okay. A lot of mathematics, calculations, theories, yeah, something like that. Okay. So this is just introduction, just very, very, very introductory part to show you the pictures and then the simplest arrangement of the lamella composite. This is the simplest one. Everything we just dump. Okay, I said everything we just dump. Example, different type of structures, size of filler, we dump into it, and we don't know what is that, and then we just say field composite, finish. So the definition, then we call it field composite. So because we don't know how to how to differentiate them sometime in more specifically or in clearly. So we can say in general, we can say it is field composite, done. Okay. So the most widely used composite of this kind, like a sandwich structure I mentioned, and honeycomb. So this word honeycomb, it is not new. Okay, honeycomb structure is not new. I think when I was a student in year 2000, undergraduate, my professor has mentioned this word already. So this word have come to me more than 20 years, more than 2 decades. So do you know a honeycomb? Okay, who else please? Honeycomb. Okay, you know honeycomb, right? It is. Then, do you know what is the beautiful part of making this honeycomb structure of composite? Why we want to change the composite? We want to design the composite into a honeycomb structure. Look like honeycomb, look like honey cave. Yeah, something can say honey. And not honey cave, bee cave. Sorry, bee cave. Okay, bee cave. Okay. Why? Any answer from you? Maybe you say you know a little bit, right? So, so going to test you now. I may say what? Very stable. Stable in terms of what? Okay, please give more specific answer because you are in science. Stable in terms of what? A lot of things can be very stable. Okay, structural stable. Okay, okay, good. What else? This is not the key. This is not the key. So I'm looking for other answer. So sometimes like beautifully stable. Jeff. See? Now Jeff always want to make joke in the class, but he's very happy. I like it, no? Okay, so never mind. So what else do you think? Structural stable, and why we want to design? The scientists, the researcher, they come up with this idea. Actually, they mimic the nature, correct? This is already available. It's a bee's cave, the bee's hives, right? So the structure of them is like that. So the scientists and researchers looks the nature so fantastic and so special, and then they use this structure in the human life, in for human life, in the product. Yeah. Other reason? High compression. Okay, can say so. Can say so, but this is not the key answer yet. See, I want to say is specific strength. Yes, okay. Okay, so thank you. So I want to, do you see that we human being, okay, we always know this word, right? Very common to us. But sometimes we never think deeply why it is invented and why these things come up, correct? And then you all will give the answer like, because of the strength, because of all these very, we call in our field, very common answers to all products. Okay, no ideas, right? Okay, of course the strength is high. You are correct. Compression strength is high. The main key things is this structure. If we design a product in this structure, we do not need to use a lot of material, and it is light. Correct, because all empty in the middle. If you really correct, the honeycomb structure is empty in the middle, like this. Yes, so less material use. Okay, less material use meaning that then we can save the cost. Yeah. So at the same time, because of this honeycomb structure, we no need to have so much material, and at the same time, like what Chai Mei say, this type of structure will give a strong, the material will become strong, and so it becomes so beautiful. That's come with this honeycomb idea, and of course, the density is low, correct? Compared to the solid compact type of design. Okay, so compact design, it looks to us in the human being eye, it will look solid. Oh, these solid things must be very strong, right? But it is not necessary, right? Not the case. But if honeycomb, we have less material. The beautiful is less material, less density, but high strength. So it makes this honeycomb so special. So even though you see the like nowadays you can see the surrounding of you, there are a lot of products are made in the honeycomb structure. Correct. So that is the main reason. So you think sometimes you ask the question, you tell the answer, you ask, is there a further down answer which is come to this, the key things why the strength is high. Yeah. Then you further question to yourself until you're not able to get the answer. Then maybe that is the key. Okay. Not easy, but it's fine. We learn until learning is all the time, is learning path. We will not stop learning. Right? Okay, classification. Just now we learned the classification of composite based on their filler. Based on the filler structure, right? So now we can use another method to how to in the classification of composite is based on the matrix, meaning that the major ingredient, the domain, yeah, I can say, right? Major ingredient, the domain, it consists maybe more than 50% of the content of the composite. Sometimes this is a traditional, perhaps it's 70%. So the major ingredient, so the polymer itself is the major ingredient, or the metal, or the ceramic. So we call it polymer matrix ceramic. That we're going to learn this in this subject, the focus. Then we have a metal matrix composite and ceramic matrix composite. So in the polymer matrix composite, it is further divided into three. So we know this very well, right? You learn this since first year. So sometimes you have to be have some level of confidence when you enter for the interview. The interviewer maybe will still ask you a very fundamental question like, oh, how do you differentiate between thermoset, thermoplastic, elastomer, and blah, 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 all these, no? So you have to still remember it until, I think forever maybe. It should be all time in your brain. How about FRP? Fiber reinforced. Oh, don't use short form. Inibra. What it is mean by FRP? Fiber reinforced. Fiber reinforced polymer. Okay. Is it same class level to polymer matrix composite or polymer matrix composite? Huh? Okay. What your question is? Fiber reinforced polymer. Okay, fiber reinforced polymer. Let me think. Fiber reinforced polymer. So something very unique. You mentioned about fiber reinforced polymer. So it is actually, Chame, where you get this phrase, fiber reinforced polymer. Good question. Paper. Okay, then what is about the paper? Not journal, just one article, right? Okay. So what is the major ingredient for this paper that you read? Fiber will produce polymer matrix composite, but fiber reinforced will produce but fiber reinforced will produce, yes. What is that journal? That paper published in which journal? Do you remember the paper that you read published in which journal? Okay. All right. So in what I can see now, it maybe means, okay, you use the polymer to produce the fiber in structure. Meaning that you use the polymer, okay, different type of polymer, perhaps the thermoset, or thermoplastic. And the polymer is usually come in resin, right? In a form of resin, in the form of, the manufacturer buy it and then they do more efforts and make them into a fiber type, perhaps. Then this fiber type of polymer, it has the reinforcement, it is reinforcing agent. Then this reinforcing agent which produce from the polymer become fiber, and it can be added into any matrix to become composite. It's something like this. Correct or not? Chai So based on my understanding is like this. Fiber reinforced polymer. So is we change, yeah. So we change, we can use polymer to produce fiber. Okay, we can use polymer to produce fiber. Like example, the cloth that we wear, it is a polyester, right? So we actually from the polyester we make into fibers, and then it has a reinforcing property or become a reinforcing agent, and we can use this type of fiber and add into another polymer, perhaps. Then this reinforcing fiber add into another polymer, it have the reinforcing effect in the composite. So I think this is what this should be clearer in such a way. Okay, so sometimes the paper we don't really want to would like to trust them. So it's very good. You study this, you read the paper, and then you come out with this question. I'm very happy. So it means that you really learn, you really put effort and put the heart to understand what you read. Yeah. So okay. Now, let me know if the answer is wrong. Okay. So I didn't read that paper, so I can't really give you the answer that they would like to express, not in the paper. Okay, so here there's a good example. This is glass fiber in the picture, and the darker color, the glass fiber is somehow in a light gray and a light gray color and a little bit whitish, no? Then at the bottom here is a darker gray color. That is the, sorry, no, that is the epoxy matrix. So this, the fiber, we call it glass reinforced epoxy, okay, composite, no? So we see, you see there's a hole, right, inside here, the picture. Do you see that? This one, the empty hole. Okay, only Chai Mei. Who else?
Yes.
Okay, bagus. Other than mother. Esther, thank you. Okay, now, so some of them, this is when the fiber pull out, you do the tensile test that for the composite, and this is a fracture surface. Then review it under the scanning electron microscopy. Now, so we see something like this, and you see if the interaction between the glass fiber and the epoxy matrix is good, adhere very well. They still adhere. So tak ada lubang. So, but some part of it, the fiber pull out, we call it, okay, the glass fiber pull out from the matrix, then it leave the hole here. So meaning that this is the weak point where the failure will start to occur at the weak point of the glass fiber not able to have a good addition with the matrix. So if semua kosong, then it's truly very weak, and then we can say this composite is a failure. So we have to do the more study and redesign the processing parameters, perhaps, no? And in order to let this happen, as you see, glass is organic or inorganic. Okay, just say ceramic is organic or inorganic. Okay. Please answer in the chat box. Glass is organic or inorganic?
Inorganic.
Jeff, okay, inorganic, right? Okay, then the epoxy is organic or inorganic? The polymer. Okay, organic. Okay, good. Okay, so do you think now you're gonna to mix these two different characteristics of material? One is organic, one is inorganic. So, okay, what do you mean by no time? Can it be mixed? Okay, my question is, can it be mixed? Okay, can't mix well, right? It can be mixed. Everything can be mixed, right? So the question is very easy. Answer also very easy. Everything we can mix. So, but needs help, yes. So now, it can be mixed. Anything you want to mix, A, B, C, D, or you can mix. So we can mix around with all the friends also, right? So, but how good it is, right? How good they can be together. That's another story. So organic, inorganic, they can be mixed, but they can't mix very well. So how are we gonna to, but we want them to be mixed. Very funny human being, right? Okay, so from who? so you see, yes, compatibilizer. So so that is why we need a third party. We call it a third party. Either it is a compatibilizer or a coupling agent. So in this case, we use coupling agent, meaning that we actually change the characteristic of this glass to become more like organic. Okay, then we only mix with the polymer. Then they can mix well. Then you will see a lesser, not that much of the fiber will pull out from the matrix. So this is pretty okay actually. We can't have a perfect picture, no, never in the world. If the people tell you this is perfect, we never have this, nonsense. Okay. Jeff asked, when do we know? Okay, good question. Okay, I like something like this. Okay, so when we know we need to use coupling agent or a compatibilizer. Okay, so they are the bridge, right? Okay, they are the bridge. And then for the coupling agent, coupling agent and compatibilizer, they have a similar characteristic, meaning that they have one end which is connect to the organic, another end connect to the inorganic. Okay, or one end is hydrophobic, another end is hydrophilic, like our soap, right? Suci tangan biar. Okay, then usually the coupling agent is more suitable to be used when we want to change the characteristic of the filler or reinforcement. Okay, and certain chemical treatment has to be done. I mean, chemistry effort, and they have this chemical reaction, we can call it. If coupling agent, there will be a chemical reaction. Okay, but compatibilizer usually it is just a physical reaction. There's no chemistry reaction behind. So you just need to mix during the hot mixing process like you do in FIP. No, you melt, mix like this. No, so you don't really do the chemical reaction and before the mixing process. So that is pretty straightforward, and usually compatibilizer is based on the matrix characteristic. It match with the matrix characteristic, it changed the matrix characteristic to suit the filler. So another way around. So compatibilizer change the matrix characteristic to suit the filler. Coupling agent change the characteristic of the filler to suit the matrix. in general, I can say something like that. And coupling agent, usually it will involve with chemical reaction. Compatibilizer usually is just a physical reaction. So which one is stronger, chemical reaction or physical? So it will create, for the coupling agent, it will create chemical interaction, and for coupling agent, it will, for compatibilizer, it will create physical interaction. So which kind of interaction is stronger? Chemical interaction A or physical interaction B? So voting time now. My question is, okay, okay, right. A, who else? How come only May and Jeff? How about the rest? Okay, thank you. Thank you, Suraya. Very good. More? Only 3 saja? Okay, cepat. Well, I think you just give the, don't be afraid of giving the wrong answer. Nobody will laugh at you. I also will not laugh at you. Okay, I will be very happy people give wrong answer actually. You know why? Then I will say more, right? I will evaluate more, right? Correct? Don't want same like me. Don't simply like that. Don't want same like me, although it's correct because you don't want to be same like me. Mati tadi. How come this siapa? Wait our Alif is so silent Last time he was very active in my class. Now Alif becomes so silent. Alif, are you here or not? Or you just place your computer there? Oh, ada. Okay. Oh, ada kat sini. Oh, sometimes, I didn't see you. You may just, place your computer there and then you go to any place, I don't know. Okay, so, what happened? Are you okay? You are hospitalized? Or don't scare me? Alif, are you okay? So you're staying in a hospital, or you visit someone, or you yourself? Okay, that's good. Okay, so all right. So wish your sister speedy recovery, right? And we will continue, huh? Okay. So you guys give the right answer. The chemical interaction is stronger, and the physical interaction is weaker. So anyway, in the industry point of view, you would like to produce a composite in the industry point of view. Which one is the simpler method? By using the coupling agent or using the compatibilizer? A, coupling agent, B, compatibilizer. Okay, B. Okay, time. Okay, May, next time you don't want to be the first give the answer, A, see Jeff in Nakabia. Oh. Lagi? These two memang. Para, okay, B, okay, compatibilizer. Okay, I know Jeff purposely he doesn't want to have same answer like me only. Okay. Okay, right. So you guys are correct. So in the industry, you will always see that in polymer, okay, in polymer, but not in electronic industry. Electronic industry use a lot of compatible coupling agent, not compatibilizer. Okay, but in this huge production of mix this and this make composite, right? They use compatibilizer because they do not need to put extra effort to treat. Okay, to treat or to modify the chemistry modification on this feeder. So you guys are right. You guys are brilliant. I'm very happy. Okay, right. So we move to the second. This is very straight. These are all the application. I let you see the pictures. Well, actually, polymer composite. Okay, some of the students, actually my PhD student asked me, she asked, Doctor, how come some people say polymer matrix composite? Some people directly say polymer composite. To me, somehow, it is quite the same. It's quite the same, but of course, these three words brings clearer meaning, correct? Meaning that polymer matrix composite, meaning that polymer is the matrix. No, so or polymer-based composite. Some people also use this, right? Polymer-based composite, meaning that the major ingredient is the polymer. That's okay. Then if let's say ceramic-based composite, so meaning that the major ingredient is the ceramic or ceramic matrix composite. Yeah. But I think my student, she's a brilliant girl, so she sometimes read and then she also sometimes not agree. She told me blah blah blah, and then we got a discussion. Then kind of happy, and then we learn together. Yeah. So, right. But anyway, we can say polymer composite is not wrong as well. I told her, yeah, it's not wrong as well. It is widely used, no. So for aerospace, we know we always feel, we always dream big, right? We want to go to the, well, okay, and the rocket, the US, the Chinese, they have been invented the rocket, and you know there's a lot of materials and investment. And recently, one American scientist just failed the experiment, right? About, I don't know, 10, how many million USD just fly in the sky within few seconds gone like that. But okay, they are a big country, they are rich, so they can do something like this, no? Right, so aircraft, you guys know it very well. Then why this picture come first? Did I mention to you before there is a big mistake done by NASA? Because they mislook the importance of polymer in the aircraft. Did I share this story with you? Reaction. I have only 8 minutes left. Ada? Not yet. Oh, okay. So you want to listen or not? Because sometimes your former seniors say I always talk nonsense in the class. So now I have to be very careful. I have to ask first, you want to listen or not? About I could check out. If you don't want, okay, fine. I will just pass. No, okay. So yes, now, I can't remember in the year 19 blah, very polymer always being forgotten. Is like people, these engineers working in NASA, they overlook the importance of the polymer. Okay, and most previously, aircraft make an aeroplane consists of a lot of epoxy. They use a lot of epoxy. Okay, that was, but now even more different type of polymer would be are used in the aircraft, making the aircraft. So in the previous time is epoxy. Then it was epoxy. Then there is an air crash happen. Really die. A lot of people die. Okay, air crash happened. I can't remember which year, but it's quite serious. In the US, no. So air crash happened, and they actually done, and after a serious investigation, they find out that this disaster happened is due to they don't the NASA engineer never hired polymer engineer. I mean never hired the employee or the technical person, the expert who knows or who knew polymer. So why it happened is because of the thermal mismatch. Like, you know, epoxy, usually it will stick with the metal, right? In the aircraft, of course, there are a lot of metal material in aircraft, correct? And then they are mixed together, or they are like a layered adhere. So due to the because you know the thermal mismatch, like example, you go to a very high altitude and there is no pressure, and as well as the temperature is very low, right? And it suddenly change, the huge temperature change, huge pressure difference, suddenly like flew out, and then it happened to the mismatch between the thermal mismatch between the polymer and the metal. So break at one component of the aircraft, then disaster happened. This is how they find it. Okay, so because of this, NASA, because of that accident, NASA now very aware to hire a material scientist or a material researchers. So this is how awesome I can say to those who knows polymer. Do you find out you are very awesome? And then you can share, you can give these stories to the people around that you are learning polymer, and yeah. So that's why, and not many people outside, they really understand the importance of polymer, and they don't actually know how to like impress the people what they learn. That is kind of difficult actually now. So thank you, May. So that's why everyone, you're proud of yourself, right? I guess. And why you proud of yourself? Because you know something which is very valuable, very interesting, very good, that you have learned, and you're so different. I can say unique from the others. But a lot of students, they do not know how to express it. They only feel, oh, I'm happy to learn this, blah, blah, blah. And then the reason is very, people will not give high intention to you. As many people will not can express something like this to get the attention, to get the interest from the audience. So then nobody care, nobody interested, right? Okay, so this is the major reason. Then the polymer become a very important material, or the polymer scientist or polymer researcher or polymer engineer, whatever. Okay, they play a very major role in NASA. Okay, so sporting groups, okay, not very dangerous already, right? And of course the beach, no. Well, when we come to the composite, biocomposite, I'm going to share later on, perhaps tomorrow. Yeah, we have 2 minutes left. So then I will share about a real story, that what the biocomposite that I really see, not really, I missed the chance to see it, but anyway, I listened to the talk of one of the Canadian professor. So he actually introduced his work, and it has been realized in the university, and it made something already in the university. It become part of the architecture in the university in Canada. Okay, so forget about it first. When we reach to that, then I will share with you. Okay, so the Hugh Beach, okay, last one. Okay, 2 minutes left, right? I want to get another very good intention. In like the freeway, but in Taiwan we call freeway, in Malaysia we call highway. Okay, and then we have these the bridge, right? The road, and then you call a bridge, and then you have this support, correct? And the support between these and these in the middle, you guess what it is made of? That is called absorber. Can you guess? And in Malaysia, we have one very proud of it. Yes, Jeff, very good. Okay, example, in general, it's called rubber. Okay, or elastomer. Okay, so this is in between, there is an elastomer as an absorber or a support, right, to connect these horizontal and vertical things. Okay, example. Then we in our country, I can't remember which highway, but last time my friend showed it during the conference. She's a very good presenter actually. She worked in the Rubber Institute of Malaysia, and then she gave an example like that bridge in Malaysia, and the absorber of this elastomer is actually made from natural rubber. So it has been long for 100 years from her, she said. So actually, it is so amazing. Don't you feel that? Yeah. So Malaysia, we have something good, but it's just we don't meet the right person, and then to tell you the interesting thing, something like that. No. So you have to go out frequently. Then you will listen to a lot of special stories. No. Next, I mean after you graduate. So this also bring a very huge interest like to the students about how good is polymer. So polymer is not just like the people outside ini plastic bag saja, ini environmental tak bagus, blah 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 kan. So you are the one who has to tell all this interesting story to the public. Okay. The car I don't need to mention so much, and okay, electronic maybe tomorrow I will share an example about the electronic is also very interesting, which can the polymers in electronic. No, okay. So, any questions? I will stop here. So, any question? And I am very happy that some of you ask questions. And the boys, do you understand? Am I very fast? I mean, the boys. Timing, no problem. But the boys, am I speak too fast in English? Or he's not in the class? Because we have 36, right? But only 31 of you turn up. So meaning that 5 of them are not here. And I'm not going to record the video. Okay. No. So no? No further question? Okay. Okay. So I think it's Mukri, right? Mukri, you asked me, or I can't remember who come and talk to me 2 weeks ago. Okay. Okay, so I'll see you tomorrow, 12:30, right? So I'm gonna to have an early lunch, then I'll meet you 12:30 until 2. Okay. Or yeah, 12:30 until 2. So I kind of would like to speed up the content. I don't want to, perhaps I know you, I try to give you an interesting story, but not a nonsense one. Okay. All right. So I see you tomorrow. I will give you a new link again. And then, okay. So bye. Bye-bye. Okay. Bye-bye. Yeah. You too. You too. You too. So anything you want me to bring from Taiwan? I'm going to Taichung later. Okay, so okay, bye. See you tomorrow. Anything. Okay, bye. Okay.